So we have to be very fast, right? I mean, I will give overview of the subject, right? So that's the purpose, right? I can't explain every concept here in short time. Hope all of you are clear with this, right? So what do we study in geography? First of all, let us take first 2-3 minutes in understanding what do we study. Then I will start. So tell me the main divisions. So we study physical geography first. Physical geography. I will human geography we will study, but I will mainly touch with physical
You're
geography.
not audible.
You may not audible.
ಸೊ ಇವಾಗ ಮ್ಯೂಟ್ ಆಯ್ತು.
ಇವಾಗ ಕೇಳಿಸ್ತಿದ್ಯಾ?
ಇವಾಗ ಕೇಳಿಸ್ತಿದೆ.
Okay, fine. So we'll study physical geography. In physical geography, we understand the concepts. Okay. So this physical geography it is all about understanding the concepts of geography. And then we study Indian geography. Here it's mainly about the concept that we apply in Indian context, and we study different aspects of Indian geography there, right? Then we study Karnataka. So at least, this should be thorough for you because these are mainly facts. For this, thank you. For this, it might take time for you to understand. So I will be focusing more on this area, right? And here, I will guide you how to study because in limited time, I cannot explain everything. So I'll be focusing where I can be helpful for in these 4 hours. Okay? Because many people find difficult here. These are the things anybody can read. And in Indian geography, few conceptual topics will be there. Like for example, climate, like especially monsoon mechanism. Many people find it difficult. So I will be focusing much on those topics. Factual content, I will try to reduce and I will inform you. We can go and revise it. Okay? Understood the objective? Okay. So also after that, we'll touch upon, in the later session, we touch upon human geography aspects also. Only which are important. Okay? Clear, everybody? So let us take up physical geography first. First section, physical geography. So what do we study in physical geography? In physical geography, we study from the beginning of the origin of the earth, right? Or the universe. Then how this earth has evolved over a period of time, right? And of that, we study different aspects of earth, lithosphere, hydrosphere, and atmosphere and biosphere. Biosphere we would cover as part of an environment, so we would not cover it here. So we study lithosphere, atmosphere, and hydrosphere, that is oceanography. For atmosphere, we study climatology. For studying lithosphere, we study. So that's important to understand. Right? So Earth has different spheres. What are those? Lithosphere, right? Lithosphere, atmosphere, and then hydrosphere. So as part of lithosphere, what do we study? Geomorphology. Geomorphology. Hope everybody is clear with this. As part of atmosphere, we study climatology. As part of hydrosphere, we study oceanography. So, understood? In physical geography, first we will take up geomorphology. Before all of this, we'll study how Earth itself has originated. Before starting all of this, we will study how itself has originated through Big Bang theory. Okay, so I will give you a quick overview on that. Okay, so this is how we should go. So in geomorphology, there are different topics like structure of the interior of the Earth, right? And the geomorphic processes, exogenic and endogenic processes. So it's a very broad topic. Within that, we study concepts like volcanism, mountain formation, folding, faulting, earthquakes, most importantly. Okay, so all of that we study here. After that, we are going to understand different theories explaining the distribution of continents and the oceans, like plate tectonics theory we study, right? So plate tectonics theory concepts I will make you understand here. Okay. So during that time, we will also discuss the distribution of mountains and other important landforms of the world. Okay. After that, we'll shift to climatology, where we understand the basics of climate, right? So what exactly is climate and what atmosphere is composed of, different layers of atmosphere, right? And atmospheric mechanisms, right? Like it could be anything: convection, condensation, rainfall, types of rainfalls, okay, cloud formation, water in the atmosphere in different forms, right? Like dew, fog, mist, all of that we study here in the atmospheric component. And we also study world climates, different types of climatic classifications, Köppen classification we study. And in hydrosphere, we study oceanography. Okay. So in oceanography, what do we study? First of all, we study the ocean relief, different zones within the oceans. Ocean floor is divided into different zones that we study, right? After that, we study ocean movements. Ocean movements could be ocean waves or currents or tides. So these three things we study. And some landforms in the oceans. Okay. So it should be really quick. I hope all of you have studied at least once. By assuming that, I'm going to start with this physical geography. So in physical geography, I have to start with the origin of the Earth, right? So just go through some of the theories. Like first person who has given a theory regarding the origin of the Earth is what? Who? Immanuel Kant. Immanuel Kant, he has given nebular hypothesis. So this is important. And later on, many people have worked on the same. Okay. There are different people like later on Laplace came up, right? And binary theories came up later on. Okay. So Immanuel Kant had given nebular hypothesis. So he explained how Earth has originated through this, right? So according to him, Earth or any other planet, or including the sun, was originated from a cloud of dust. In the empty space, there was nothing other than cloud. This cloud was containing gases, gases like hydrogen and helium and dust particles. Okay, so this cloud would be called as nebula. Okay, so this is important. They might ask what is nebula in simpler terms, right? So what happened? The matter, this gas and dust was not equally distributed in this cloud. Understanding? So this mass of cloud and dust was unequally distributed. In few places, it was excessively concentrated. In few places. So this higher concentration at some point, what has created? It has created higher density in this. Correct? So higher density creates higher mass, right? So it started attracting mass, dust particles and the gases from the other places. So this density further increased. Density further increased. Correct? So it became like a core that developed a core part, right? How had this core part developed? Because it started attracting matter from the other sources, right? So what happened? Due to many factors, what happened? It started rotating. It started due to collision. Few people, I mean, Laplace said it is due to temperature decrease with condensation here, but Immanuel Kant said it is because of the collision between particles. It started rotating. Basically, this ball started rotating. What happened? A core developed surrounding to that, a disk formed. In this disk, what it contained again? Same dust particles, right? So here also matter condensed, and they started separating into different layers to form planets. So the central part became sun. So basically, after all of this, what you have to remember is the sun and the solar system. The sun and the solar system was created out of nebula, because in the nebula, the dust particles are not equally distributed. In some places, it was excessively concentrated, that led to the origin of a core surrounding that. A plate disk was formed, and within that, planets were formed. Understanding this? Okay. So similar theories were given by different people. More or less, they're similar. No need to get into details of all of them. Okay. Like later on came up binary theories, like Jeans and Jeffrey, for example. So binary theory says that there was this sun. For sun, there was another companion star, another star. This star passed by the sun, passed near by the sun. This star just went from here. What happened? It has its own gravity. Correct? So it attracted some particle from the some part of the sun towards it when it passed close to the sun. So this led to the separation of matter from the sun. But this star passed away, right? I mean, it passes away from the sun. But this matter which ejected from the sun, it started revolving around the. What happened? It started revolving around the sun, forming a disk. So this again condenses same. You know the story after formation of a disk. Once the disk formation happens, the matter will again get condensed within that to form planets. But here the how disk was formed, because of the gravitational pull of the another star which just passed by. So these theories are binary theories, right? So there are two theories like this. Another one was gaseous filament theory, right? So which is more or less, explanation is more or less same. So don't worry much about it. So in all of this, the discussion was only about how Earth was originated. But later on, what happened? Question came up about the origin of the whole universe. Here they were discussing only about the formation of sun and the planets. But later on, the discussion and the question came up about the origin of the entire universe. For that came up one theory called, all of you know that, this is Big Bang. Big Bang theory. Big Bang theory says that there was this single point in the beginning. This single point had infinitely small volume. Infinitely small volume. You can't even observe, you can't even think how small it was. You can't even imagine that small. In this small point, there was infinitely high temperature. Highest temperature. You can't even imagine how much temperature was concentrated in the smallest of the volume in the space. Right. So yes. So this point is what? Infinitely small, has infinitely small volume, infinitely high temperature and the pressure. So this point was called singularity. What is it called? Singularity. You can't even imagine. Trust me. What is it? So such a point is called singularity. See, what happened at one point was the temperature has become so infinitely excessive that it explodes. It does not explode basically. It expands. Suddenly it expands. Suddenly it expands. Suddenly it expands. So what happened? This point had infinitely high energy, right? Which was concentrated in a very small volume, right? So sudden expansion led to the release of energy. What happened? Sudden expansion has led to the release of energy. So release of energy, what happened? With the release of energy, the energy got converted into matter. Okay, so this might be very difficult to understand. Energy, but just remember it, energy got converted into matter. So in the matter, most fundamental particles found first, like quarks, right, leptons, and such fundamental particles like photons and all. So basic later on, what happened? Those fundamental particles combined together to form atomic particles like protons, neutrons, and electrons. Later, they combined to form nucleus and the atom. So that is how atoms formed. So atom formed. The first atoms formed was of hydrogen and helium, right? So later on, eventually, what happened? That formed into nebula. You know the story after nebula. What happened? Once nebula formed, it will convert into planetary system. So this was the theory given by Big Bang. Correct? So in the same Big Bang series, in the same Big Bang theory, they have also explained how Earth formed and how Moon formed. All of that. Okay. So, so first of all, let us understand from nebula. Basically, what happened? So, what is nebula? Cloud, cloud of dust and gases. So it was like infinitely extended, right? Was nothing in the universe, nothing in the no star, no planets. So initially, what happened? The matter started congregating at one place. That had led to formation of galaxies. Okay, so galaxies, right? So galaxy nebula two. Within nebula, galaxies started forming. How galaxies have formed? By the congregation of the dust particles and the gases. So within galaxy again, as I've explained, star formation happened. Star and surrounding the star on disk developed. In the disk, many planets were formed. Okay, just remember this, right? And timeline for this Big Bang, that sudden expansion. That sudden expansion was called cosmic inflation. Always remember, the sudden expansion is called cosmic inflation. So the theory that I explained just now, where there was single point, from that single point, everything got expanded, right? That sudden expansion within milliseconds, that expansion is called cosmic inflation, right? Cosmic inflation. So what happened after that? Universe is expanding. Universe is expanding. Earlier, there was no space. Now space has created, right? And also time. So what is happening in the space is also extending. So after around 5, 6, this happened around 13.8 billion years. 13.8 billion. 1 billion equals to 100 crore. 100 crores, right? So 13.8 billion years ago, this Big Bang happened. So around 5 to 6 billion years ago, this galaxy and star formation happened, right? Around 4 to 5 billion years ago, planet formation started. So Earth formed 4.5 billion years. Okay. So star formation happened 5 to 6 billion years. You can see that if you have insight, you can observe that the space between galaxies is increasing. So remember this. So in exam, if they ask you, like space within galaxies is increasing, it is wrong. Space within a galaxy is not increasing. Space in between galaxies is increasing. We should highlight that. Understanding this? Space between galaxies is increasing. And regarding the formation of Earth and other planets, same story. Okay, no need to just again revise them. There was one core formation happened, that is the sun surrounding the disk formed. In the disk again same. Initially, what happened? these again nebula particles in the disk surrounding core. This core is sun. So there was a disk surrounding it. Within this, again, small particles were there, dust particles and all. So they also, what happened? They congregated, right, to form these smaller bodies, smaller rocky bodies. These are called planetesimals. If in case they ask what is planetesimals, these are what? Somewhat bigger or again less than planets. Okay. So the small rocky bodies combine to form somewhat larger bodies. They are called planetesimals. Again, these planetesimals combined, all of these planetesimals combine together to form planets. Understanding? So asteroid belt you see, right? So there are smaller rocky bodies. So such type of rocky bodies formed initially to form the planets before the formation of the planets. So such type of rocky bodies are called planetesimals. If in case they ask what is planetesimal, you should know. So you know that sun and the formation of earth you have understood. So next regarding formation of moon, there are two theories to explain formation of the moon. Okay. So one theory was given by Charles uh, George Darwin. George Darwin. Charles Darwin is different, right? So what happened? Said that initially Earth was this dumbbell shaped. So this is the Earth and this was the moon, and this body together was rotating in high speed. So with that high speed rotation, what happened? The moon separated from the Earth. So this was given by Darwin. But this is called dumbbell shaped theory. Dumbbell, or you can say dumbbell theory or something. Right. We can name it such. What happened? Due to high speed rotation, the moon separated from the Earth. But this theory is not accepted now. Okay, because another theory came up which said that is mostly accepted today is that there was this Earth, there was another planet in our solar system. In our solar system, there was another planet which is not now. The name of that planet was Theia. So this Theia collided with, so its size was less than Earth, right? So this Theia collided with Earth. Once it collided with Earth, what happened? A matter ejected. So this completely got destroyed. Earth survived. Earth survived, but this Theia got destroyed. So matter from the Earth got ejected into the space, right? So it started revolving around Earth, this matter, and within a few hours, what happened? All of this matter got again condensed into moon. So this is how moon was formed due to the collision between Theia and the Earth. So understood how Earth formed now? How universe formed? Okay. Everything has come from one single point. Everything, whatever that exists in the universe today that we see, that has come from one point. That point is called singularity. So few things you should understand in the universe here. For example, what is light year? So in the universe chapter, you should remember what is light year. Light year means, so light year is the measure of distance. First of all, it's a very simple GK question. What is light? Light year is a measure of what? What? Okay, it's a measure of distance, not time. Okay. By observing it is here, don't assume that it is a measurement unit for time. It is not for time. It is for distance. So what exactly it is? The distance traveled by a ray of light in 1 year. So you know that a ray of light travels 3 lakhs kilometer. 3 lakhs kilometer, right? So it is 3 into 10 to the power of 8 meter. So if you want to write it in kilometer, 3 into 10 to the power of 5 kilometer per second. In 1 second, it travels 3 lakhs kilometers light. So a light which travels 3 lakh kilometer in 1 second, when it travels 1 year continuously, how much distance it shall cover? So that distance is called that distance is called light year. So that is why it is a measurement of light distance. Another unit you should remember here, astronomical unit. AU. Astronomical unit. Astronomical unit. So what is astronomical unit? So this is the one astronomical unit equals to 115 crore or 150 million. So 150 million equals to 15 crore. You just divide 10, you will get in crores. So 1 A equals to 150. Why this is the unit? Because this is the distance between Sun and the Earth. Sun and the Earth. So this distance is 150 million. Correct? Distance is 150 million. So this is called 1 AU. So if you calculate it, it will come like that. A ray of light which travels 3 lakhs kilometers per second to reach Earth, it takes 8 minutes. 8 minutes. 8.2 8.2 minutes. 8.2 minutes. Okay. So the distance between Earth and Sun and Earth is 1 AU. So that is used as unit to measure the distance in our solar system. To measure longer distances in our universe, so distance between two galaxies, the distance will be too long. So there we use light year. Understand this? Okay. So our solar system, at the center we have Sun. Nearest solar system of this, our nearest solar system of our solar system is what? And you can say nearest Sun, nearest star to the Sun. What is that? What is the nearest star to the Sun? Proxima Centauri. So these are some of the facts you should remember. Proxima Centauri is the nearest star to our Sun. So it has its own solar system, we can say. So Proxima Centauri. Proxima Centauri. This is a dwarf star. This is a dwarf. Dwarf red star. Dwarf red star. Whatever. It's a red star. Red. Why it is red? See, whenever if the star. Yes. So the color is of the star, any star is measured based on the temperature. If the and it's again depends upon the size. If the size is less, what happens? Any star, if size is less, it burns fuel slowly and it lives longer, and its temperature is also less. So because Proxima Centauri size is less, that's why we're calling it as dwarf, and its temperature is also less, so it is red in color. And medium temperature, medium sized stars like Sun appears yellow in color. Appears yellow in color. Like our sun is yellow in color. And bigger stars like Sirius. Okay, so that is the brightest star or biggest star in our galaxy. That is called Sirius. So these people, these stars shine in white color. Why are they white? Temperature, the color changes with respect to temperature. Understanding this? So with that, you also understood that small stars which have low temperature shine in red color. Okay, they appear red in color. Medium stars like Sun. Sun is a medium sized star. Color is yellow. And for bigger stars, the temperature is high. They appear white in color, like Sirius, right? Huh? Blue or else ಇನ್ನು ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇದೆ white. Blue or white. Okay. For example, center of the sun is white in color. Correct. So let us take up sun, structure of the sun, right? So solar system, I wanted you to do it on your own, but still I'm covering important points. So there is this sun. We'll understand how sun looks like inside, right? So sun has 3 layers inside. So inside there is core, radiative zone, and this is convection. Why I'm drawing like this? So it is also important to understand why I'm drawing like this. So it is core, for example. Core has highest temperature. All the fuel of the sun is concentrated here. What is the fuel of the sun? Hydrogen and helium. So in the universe, the highest element is what? Hydrogen. Correct? In the universe, the highest large spread element is hydrogen. So in the sun also, there is hydrogen and helium both. But more than 90% of sun is made up of hydrogen. Remember it. And rest of the element is helium and a small quantity of carbon. Understand this? So you can say sun is made up of hydrogen, helium, and a very small concentration of carbon. So what does it shows that sun has more amount of hydrogen? It shows that sun is still young because he has sufficient fuel. He has sufficient fuel to burn, right? So what happens in the core is there is a process called nuclear fusion that happens. Nuclear fusion means sun has hydrogen, two hydrogen meet, combine, to form helium. So this process is called nuclear fusion. Nuclear fusion. It's not fission, it is fusion, right? So fusion occurs at high temperatures. Fusion always occurs at high temperatures. So such temperature is available only in the core of the sun. On Earth also we are trying to do this, imitate this process, but it is difficult because we cannot create such high degree temperature. So there is temperature more than 15 million degrees Celsius. 15 million degrees Celsius. So nuclear fusion happens in the core of the sun. So this produces a lot of energy. What happens in this process?
Produces
Lot of
energy
energy
in the form of
and light. Okay, light also it produces, right? So any celestial body, if it has to be regarded or called by the name of a star, the main criterion is it should have nuclear fusion process. Why Earth is not a star? Because there is no. This is the main criterion. Sun is a star because there is nuclear fusion going on, which produces its own heat and energy and light, all of that, right? So light is producing here, photons are producing here. These photons radiate here. These photons radiate. You know what is radiation? Transfer of heat when two bodies are not in contact with each other. So this is called radiative process. So this heats up this third layer. Third layer is what? Convective. So here what happens? This is all in plasma state. Which state? Plasma state. So here what happens? The heat transfer happens in the gas in plasma state, right? Vertical transfer of heat is called convection. So as it comes to the surface, it cools because temperature here is more than this, right? So what happens when it cools? It will go back again. But when it reaches this radiative zone, it heats up again and it will rise again. So there is this cycle, which is called convection cycle. So this is why this layer is called convection cell. Second layer is radiative zone, where a photon is radiating. It takes millions of years for photon to travel from here to here. Once it reaches to the surface, it takes only 8 minutes to reach Earth. But here it is spending millions of years. Understanding this? Okay. So core, radiative zone, convection. So this upper layer again in the atmosphere is called photosphere. So these three are interior parts: core, radiative zone, convection, interior parts. Exterior part, the first layer is what? Photosphere. And the second layer is and the third layer is corona. So this chromosphere is very small, thickness is small, whereas this corona is extended for millions of kilometers. So this is the atmosphere of the sun. These three layers, these first three layers are the interior parts of the sun. These are part of atmosphere of the sun. Whereas this corona is the outer layer. It's very important to understand, right? And it is what? Extended to millions of kilometers. Okay. So what happens at the surface of the sun? The temperature is surface of the sun means always photosphere. Remember, photosphere is the first layer, right, in the atmosphere. So this is called surface of the sun. This is what it appears to us in yellow color. Photosphere. The visible part of the sun always is what? Photosphere. So the temperature is around 6,000 degrees Celsius. This temperature exactly equal to the what? There is temperature at the core of the earth. At the core of the earth, what is the temperature? Earth centrally, at the center of the earth, there is 6,000 degrees Celsius temperature, which is there at the surface of the sun. At the core, there is 15 mil. This is the hottest part of the core, is the hottest part of the sun. Okay. So let me explain few more concepts of sun, which are important for exams. Like for example, this is the structure of the sun. Sun also rotates. Remember that. Okay. Sun also rotates. Sun also revolves. So sun revolves around whom? Center of galaxy. Our galaxy is spiral in shape. So there are different types of galaxies, like spiral shaped, elliptical shaped, and other irregular shaped. Example for spiral shaped, our own galaxy, Milky Way. Okay. So at the center of Milky Way, there is one black hole. The name of this black hole is Sagittarius A. Right, Sagittarius A. So this is the black hole. So always remember, wherever there is black hole, it has high gravity, infinite gravity. Correct. So this gravitation pull is so strong that all stars revolve around this center of our galaxy. Right. Just like our Earth planet revolves around sun, all the stars in our galaxy, including our own sun, revolves around the black hole. Understanding this? Okay, sun also revolves and sun also rotates. Okay, so he takes 250 million years to complete one revolution and around 25 days to complete one rotation. So what happens here is, yes, so we are discussing this is sun, right? So sun rotates in counterclockwise direction just like our earth. You know what happens at the sun? There are some dark patches here and there. These dark spots are called sunspots. Sunspots. So the sunspots are areas where there is high magnetic field. Always remember, sunspots are the areas where there is high magnetic field. Magnetic field. Okay. So this magnetic field prevents below that there is convection layer, right? So convection layer heat is transferring from lower layer to upper layer. This high magnetic field is preventing that heat to come to the surface. So that's why these areas are polar areas. Always remember, sunspots are polar areas in terms of temperature. Their temperature could be around 4,000 degrees Celsius. Otherwise, in photosphere, the temperature is around 6,000. In these places, there can be around 4,000, 4,500 degrees Celsius. So, and also they are high magnetic field areas. So what happens sometimes, there is something called this magnetic loop. Okay, magnetic loop. Below that there is sunspot. So there is another sunspot here, and there is another magnetic loop. So what happens? They can twist these. They can twist these loops can get twisted, and they can merge also sometimes. So they get disturbed basically. Once they get disturbed, what happened? They will get ejected from this. Suddenly they get separated. Okay. So suddenly they get separated. So this magnetic field has separated from the sun. Earlier it was here, right, above the sunspot, but now it's separated. Now this is traveling, right? Now it is traveling in all directions, right? So here there are planets like Mercury, Venus, and Earth also here. Earth is also there, right? And this magnetic field is also carrying charged particles, because sun is all about charged particles, plasma state, right? So what is this called? This is called solar flare. This is called solar flare. So solar flare. So now tell me, if there are more sunspots on this Earth sun surface, solar flares numbers will also be high. It also increases. Understand this? So what happens? Sun runs in a cycle. Sun's activity increases and decreases according to that cycle. Every 11 years, sun cycle reverses. Okay. So that's called solar cycle. In solar cycle, it is all about sun's activity. You know what happens? If in solar cycle, what do we study? There is solar maximum. Solar maximum. After 6 years, solar minimum. Solar minimum. This is not exactly 6, around 5.5 or something, right? You can consider 6 years. So there is 6 years difference between solar maximum and solar minimum. Solar maximum means the sun's activity is highest, right? Solar minimum means sun's activity is lowest. After another 6 years, solar maximum occurs again. Solar maximum. So it roughly they consider 11 years. It should be 12, but it's not exactly 6, right? That's why we consider what? 11 years. So 11 years is the period of solar cycle. If there is solar maximum, for another solar maximum to occur, how many years? It takes 11 years. Okay. So what happens in solar maximum is number of sunspots increases. Number of sunspots increases. When number of sunspots increases, what happens? Number of solar flares also increases. So that is threat to Earth and all other planets. Okay. So like that you study remaining topics also, right? Like there is something called solar wind. Solar wind is emission of charged particles. That is constantly solar wind is traveling in all, getting ejected from the sun and traveling in all directions. This is nothing but charged particles emitted by the sun. Okay, this is solar wind. So that if it is associated with the magnetic field, then it is called solar flare. Okay. So yeah, solar. We have come to solar system basically. So let us discuss in let us have a brief discussion about our solar system also, like planets. So sun, how many planets are there? I will give structure of our planet. Sun, there are how many planets? 8 planets. Earlier there were 9. So ninth one was what? Which one? Pluto. Pluto now it's not a planet, right? Why it is? It was discovered in 1930 and it was classified as a planet. Pluto was classified as a planet in 1930, but in 2006 they have removed it from the category of planet because they have given a new definition for planets. According to that, the planet, any body can be called planet once it based on three conditions. What are those? Huh? So it should have one orbit. Orbit. It should revolve around the sun in a definite orbit. First point. Second planet is it should have sufficient mass that it can maintain that hydrostatic equilibrium and form spherical shape. So this is about shape. So it should be in what shape? Spherical. Here, right? Right. Pluto has satisfied both of these. Pluto revolves around sun in a definite orbit, and it also has spherical shapes. And the third criteria which Pluto could not fulfill the criterion was third. Okay. For those who don't know, listen here. So it should be what? Third, it should clear its path. Clear its path. Clear its path. What does it mean? You know, when a planet is revolving around the sun like this, there should be not other bigger bodies around, right? So it's like this planet should be the king of this orbit. If there is any other body nearby it means that this body does not have sufficient mass enough to attract that planet, right? If it has sufficient mass, there would not have been other planets. For example, if Earth is revolving, there is no other nearest other planet or any other body which disturbs the orbit of the Earth. But this criteria was not fulfilled by Pluto. So that's why it has been removed. But still it is what? It's a dwarf planet. So if any body, if it satisfies these two conditions, that is called dwarf planet. So there are other dwarf planets in our solar system apart from Pluto. Tell me some of the names of them.
Aries.
Aries, right?
Aries.
So this is the largest dwarf planet. And apart from that, Meg.
Pluto.
So which is the dwarf planet present in our asteroid belt?
Ceres.
Yes. So this is right. Ceres. Okay. So structure of our solar system: Sun. Tell me the planets: Mercury, Venus, Earth. Okay. Mars, Jupiter, Saturn, Venus, Neptune. Right. So I will draw it like this. You will understand in a better way. So there is at the center there is Jupiter. Jupiter is like almost like a star. It is such a big planet. So what happens on both the sides? Planet size decreases. Saturn lesser than this. Then Venus lesser than this in terms of size. Neptune. And here also same happens. But there is one exception, that is mass. Mars is very small than Earth. So Earth, then Venus is smaller than Earth, then Mercury. Correct? So which is the biggest planet in okay in so here, okay. So what we do is we'll draw a line here. This line is called asteroid belt. Asteroid belt. There are some rocky bodies here. Okay. So rocky bodies, they're revolving around sun. And after all these planets, there is one more belt. I will draw it here. There is one more belt. This is Kuiper belt. Kuiper belt. Kuiper belt has icy objects. Why icy objects? Because it's very away from the sun. That's why the temperature is low. Right. Understanding this? Okay. So these are called inner planets. So we take this line as a boundary. What line? Asteroid belt. So these inner planets, outer planets. So these are called terrestrial planets. Terrestrial. Inner planets are called terrestrial planets. These are called Jovian planets. Jovian means Jupiter-like. All of them are Jupiter. Why? They are gases. All of them are what? Gases. So these they do not have hard surface. That means lithosphere surface they do not have. They have gaseous surface, right? So they have thick gases. That's why they are gaseous. Whereas all these four are Earth-like because they have solid surface. Understand this? All of these planets have solid surface. And a few other points. Yeah.
Is Kuiper's belt part of heliosphere?
Of course. Heliosphere is the end of boundary of our entire solar system. So we are studying our solar system. That means Kuiper belt should be part of heliosphere. Okay. So why they are rocky bodies? There are a few reasons, like there is sun. Consider there is sun here. Are you following me? Okay. So there is sun. Sun has become way more close to Mars. So whatever. So sun, right? Sun is sending the solar winds and solar flares. Already we have studied. So that has removed the atmosphere from Mars. Sorry, this Mercury and Venus is thick atmosphere, right? But whatever, the gases, the atmosphere are not so thick as as they are in the outer planets. Here the atmosphere is very very thick because they're gaseous bodies. Here atmosphere is not so thick compared to Jovian planets because the solar wind has removed all of them. And one more point is they are away from the sun. That means temperature here is less, correct? Because they're away from the sun. So that has made the condensation of the gases. So that's why there is thick atmosphere. Here there is temperature is higher, so where gases can evaporate and escape. Understand this? So that's why they have solid surfaces, they have gaseous surfaces. Some other differences you can go and revise. So Kuiper belt, the Kuiper belt, and this is asteroid belt. You know what is asteroid? Asteroid is some rocky objects revolving around the sun, just like all of their planets. But their size varies from millimeter to almost like a planet or dwarf planet, like Ceres. It's a dwarf planet. Size varies. Okay, and so regarding that, asteroid. Sometimes what happens is asteroids deviate from their path. Right. Sometimes what happens? They deviate from their path. So here there is an asteroid. It deviates from their path, either this side or that side. Okay. So when it deviates, what is it called? It is called meteor. It is called, when it deviates, it is called meteor. See, asteroid, meteor. Just it has got deviated from the path. Once if it enters in the, for example, if it is hitting to the earth or it is coming towards earth, once it enters to the atmosphere of the earth, what is it called?
Meteor.
Huh?
Meteor.
Meteor. It's just called meteor. Right. So meteor burns in earth atmosphere. In which layer of the earth it burns? No. No. Mesosphere. Yes. Mesosphere. Yes. Mesosphere. So it burns in mesosphere. Why in mesosphere? The reason is that mesosphere is the first layer where some sufficient density of masses, air mass is available for this meteor to create a friction and burn. Right? Okay. So meteor, once it hits to the earth, most of it burns. Sometimes few meteors, they reach the earth surface. Once it reaches the earth, what is it called? Meteorite. Meteorite. So Pluto is in which belt? Easy in any, yes, it's in Kuiper belt. Okay. So just also look for other things about solar system. I have just given brief overview. So we'll shift on to other topics quickly.
Meteorite andre?
Already 1 hour passed. Huh?
Meteorite.
Meteorite is when meteor reaches Earth. That reached part is called meteorite. Right. So next we'll study interior of the Earth. So we have studied solar system and universe. Let's come back to Earth and study Earth now. Okay. So Earth interior we study like this. You should study the different layers of the Earth. So there is upper layer is crust. First, there are 3 divisions basically: crust, mantle, core. So these 3 basic divisions everybody should understand: crust, mantle, and core. Correct. Okay. So again, we divide crust into two types. Crust only 2 types. There is this continental crust. Below that there is oceanic crust. Oceanic crust. This is continental crust. Mantle again we divide into 2 types: upper mantle and lower mantle. Core also again 2 types: outer core and inner core. Outer core and inner core. Let me draw again. So what I've told you in the First there is, these are like continental crust. Below that there is oceanic crust. Actually, it's very, very thin, like 100 kilometer, not 100. It's around 40 kilometers. Yes, around 40 kilometers. You are talking about, I think you are talking about lithosphere. So below that there is
The thickness of
crust,
crust.
crust, overall crust. So in that thickness of, it is not fixed, right? Average, I'm telling. Sometimes it can be as thick as 70 kilometers. Sometimes 70 to even 80, 90 kilometers. Where there is mountain. See here, there is mountain, right? For example, consider this is Himalaya or Mount Everest. So Mount Everest has deeper crust. Of course, because ಅಷ್ಟು ದೊಡ್ಡ ಮಾಸ್ ಮೇಲೆ ಇರಬೇಕಂದ್ರೆ ಕೆಳಗಡೆ ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಕ್ಕೆ there should be deeper crust. Understanding this? So actually this is called isostasy. Technically it's called isostasy. I mean, at the above the crust, more the mass of the crust is there, below which there is sufficient mass, I mean equivalent mass to balance the mass on the surface. That is called isostasy. You can remember it if in case they ask isostasy. Very important. Okay. So 70 kilometers is the depth of the crust in few places. Average is 5. But whereas the depth or the thickness of ocean crust is very small. It's around 5 kilometers. Around 5 kilometers. Okay. So we'll discuss crust again. So next, upper mantle and lower mantle. So this is the major part of the earth by volume and also by mass. This is the major part of the earth. By volume, it's more than 80%. Okay. After that, there is outer core and inner core. What happens with increasing depth? Temperature. For temperature increases with increasing depth. Density also increases. Density is most important thing, right? So what is the density at the crust? At the both crust, it's around 2.7 gram per cm cube. And at I mean, this is continental crust. At oceanic crust, it's around 2.9. Next, upper mantle, it's around 2.9 to 3.3. 3.3 something. After lower mantle, it's from 3.3 to
5.7.
5.7. And in outer core and inner core, it is way more high, like 9, or maximum density could be more than 13, around 13 in the inner core, right? So know that density, you can remember the values. Okay. So these are what? Density is increasing and temperature also increases with the depth. So highest temperature will be in the core, of course, it's around inner core 6000 degrees Celsius, right? Okay. So let us discuss something about crust again. Crust is of two types: continental crust and oceanic crust, right? So continental crust is made up of silicon and aluminum, major elements, and oceanic crust is mainly made up of silicon and magnesium. So here magnesium is denser than the aluminum. That's why oceanic crust is more denser. Always remember, oceanic crust is more denser, more stronger. Which is more stronger and more denser? Why? Because it has magnesium along with silicon. So in the crust, you can say silicon is in high quantity, right? Okay. So magnesium. And densities are now varies 2.7. You can see the variation in the density. That's why it is 2.7. It is 2.9. We are saying it is more dense than the oceanic crust. Correct? So yeah, after that we study mantle. In the mantle, okay, in the mantle there is one special region here. What is this layer called? This is an asthenosphere. So asthenosphere is a layer which contains molten magma. So rocks are molten there. Why rocks are molten there and at this depth? Huh? Because of high temperature. With increasing depth, what happens? Temperature rises. So that is why here rocks also melt. So in this layer, there is what? Molten magma, right? Which is called asthenosphere. So this is the main source of lava. whenever there is volcanic eruption happens, from this is where this magma erupts. When it comes to the surface, it is called lava. Correct. Okay, we'll come back to this again. So it is asthenosphere is situated in which layer? Upper mantle. Right. So why the below layers would not melt? Why only here? That's the question.
Pressure is more than the temperature.
Yes. So there is like always like fight between temperature and pressure. What happens with increasing depth? Temperature increases. Fine. That's why all of it has to be melted. But at the same time, pressure is also increased. If the pressure is more powerful, it will prevent the influence of high temperature. So with increasing depth, pressure is increasing. That is why they are not melting. Okay. The same understanding you will get here also. Outer core, inner core. Okay. So in outer core and inner core, if you can say outer core is what? Liquid. Always remember, outer core is liquid. Inner core is solid. Correct? Outer core is liquid. Why outer core is liquid? Why inner core is solid? Given the temperature is more in the outer core. Here around temperature around 4,400 something degrees Celsius. But here temperature is 6,000 degrees Celsius. But it is molten form. Because again it is the pressure. Here the pressure is so high that it will prevent anything from melting. Here pressure is so high that it will prevent any material from melting. I know these outer core and inner core made up of which elements? Nickel. Yes. So this is what? Nickel and ferrous. Nickel and iron. So iron and nickel are the main elements here. So here molten form is iron and nickel are in molten form. Right. Here it's not iron nickel. They're different elements like silicon, aluminum. Yes. Yeah. Regarding pyroclastic material, let me tell you this is what this not regarding that, but consider that this mantle is in plastic state. Mantle is in plastic state. It is not completely solid like crust, and it's not liquid like other layers like outer core. It is in the plastic state. Understanding this? Okay. So we have to discuss one more thing here. Something called lithosphere. Lithosphere. So what is lithosphere? So lithosphere, if you have to define it, it is the outermost solid layer of the earth. So below a liquid layer. What is that below liquid layer? Asthenosphere. So whatever the solid part is there above asthenosphere, that part is called lithosphere. So what are the parts which are above asthenosphere? There is this continental crust, there is oceanic crust, and upper mantle starts with. So part of upper mantle, in that there is asthenosphere. So there is some part which is part of upper mantle, right? So this entire region, this entire part is called lithosphere. So lithosphere contains upper crust, and that is the oceanic crust, the continental crust, oceanic crust, and the solid part of upper mantle. Remember, solid part of upper mantle. So this is lithosphere. So this lithosphere. (200 kilometers). So this asthenosphere is located around at the depth of 200 kilometers. Here temperature is around 2000 degrees Celsius in asthenosphere. So what is lithosphere? It's very important to understand what is lithosphere. Lithosphere formally upper continental crust, oceanic crust, and the solid part of upper mantle. Okay. Now let me tell you. I mean, from this I will take on to the next unit, that is about plate tectonics. Okay. So I'll explain plate tectonics directly. Before this, later on I will explain other theories. So what happened is this lithosphere. Lithosphere is what? Above asthenosphere. It is floating. So lithosphere is like floating above asthenosphere, right? Asthenosphere is a liquid layer, or you can say in the molten state. So above this asthenosphere, this lithosphere is floating like a ship, right? And this lithosphere is not continuous. It is broken. It is broken into blocks. Into blocks. This lithosphere is broken into blocks. This one block is called a plate, tectonic plate. What is this called? Tectonic plate. Tectonic plate. tectonic plate. Okay, I will simply explain you how the process is going on. You can go and read different theories on this. Okay, so this is what tectonic plate. What are there? Radioactive materials. Those radioactive materials decay. When they decay, they emit radiations. When they emit radiations, what happens? The temperature rises. The temperature, what happens? Travels to the surface, to the near this lithosphere. This is called convection, right? Vertical transfer of heat is called convection. So there is this convection happening in the mantle part, mainly in the mantle part. This is called mantle flume. What is this called? Mantle flume. Assume right now there is one continuous lithosphere. Okay, I will explain how this lithosphere got broken. What happened? The energy is coming from the deeper part of the earth at the boundary where boundary of outer core and the not inner core, outer core and the mantle, lower mantle. Okay, and how this energy is generating, that's important to understand. From how this energy is generating here, not radiation, that's it. Emission, decay, that's decay of radioactive material. Okay, another reason the for the origin of the energy here is the primordial heat, something called primordial heat. Also remember this, there is this primordial heat. What is this primordial heat? See, when earth was forming initially, okay, earth temperature is very high. Earth is cooling from then. Since then earth is cooling slowly. That cooling process has not stopped yet. It is still cooling. That means the energy it is carrying from the beginning, it is still there in the core, outer core and at this region. So that energy is also traveling towards the surface. Understanding this? So because of that, energy is traveling from here. This is called mantle flume. Mantle flume. So this mantle flume, when it hits here, what happens? When it hits to the lithosphere, what happens? It will develop cracks like. What happens? It will develop cracks. Correct? Sometimes what happens? There is this asthenosphere, there is magma. This magma travels through the called fault zone. Fault means a weak zone, right? So this will develop fault. What happens? 3 blocks created now. 1, 2, 3. Middle part, what happens? It falls down. Middle part falls down. So remember here, it will be like this. The middle part earlier it was here, it has come down, right? Because of this. So here there is volcanic eruption. Correct? So this is called drift. It is called drift. Correct? Okay. After that, what happens? This energy diverges from here. Follow this energy. Follow this. It is coming from here. It diverges here after hitting to the plate. Right. So what happened? This energy is diverging on both sides. Right or wrong? Diverging both the sides. When it diverges, it also carries these plates away from this end. So these 2 plates are separating. This plate and this plate are separate near this rift zone. Another plate. There is another plate here. Storing here also same. The energy is coming from the core, outer core, and the mantle boundary. This is called mantle plume. It is also volcanic eruption. It is also causing volcanic eruption and a fault zone. And the middle block is falling down, creating a rift. And it is also diverging. Correct? I'm replicating the same process here, diverging. Right. But what about here? These 2 plates. These 2 plates are coming to. They collide like this. They collide. Here, the energy, both these energies meet. They meet at this point. After meeting, they will go down. Okay. They go down. When they go down, they heat up again. When they heat up, and they will again come to the surface. So you can see cycle going on here. Here also there is cycle going on. Correct? This is the story in the mantle. But at the crust in the lithosphere, what is happening? Plates are either diverging or coming together. When they come together and collide with each other, this boundary is called convergent plate boundary. Convergent plate. Okay. So let us take up this in the another slide. So two boundaries are coming together and colliding, right? So here, consider this is a continental part. Continental part. This is land part. This is oceanic part. Oceanic part has sima, magnesium. Magnesium is denser, means more stronger. So this is continental part. It has Cl, which is lighter. So because it is more stronger, when they collide, what happens? This will get inside this, right? This is called subduction. So here, the denser part is subducting inside the lighter part. This is called what? Subduction. So remember this process. Subduction. So it might be a bit clumsy. Please try to cooperate. Yeah. So this is the zone of subduction, where denser plate is subducting inside the lighter part. Below that there is asthenosphere, right? Asthenosphere. So what is happening? This subducted part is coming to the asthenosphere where temperature is high, so it also melts. So this part, once it reaches asthenosphere, melts. This part gets melted. That means crust here is getting destroyed. The lithosphere is getting destroyed in here. Correct? Getting destroyed. So it will become magma again. Again, it also raises temperature as well as the pressure over here because it is subducting. In this season, there is increased pressure. So what happens? This increased pressure pushes the magma to come to the surface line. Whenever there is subduction happening, this increases pressure in this region. Increased pressure here will cause the magma to erupt through the cracks by developing weak zones and coming to the surface. So here developing volcanoes. Correct? So assume we are in the ocean now. This is also in the ocean. This is also in the ocean. What happens? There is volcanic mountain is getting created in the ocean. We are in the ocean now. Are you following me? Everybody? Anybody have gotten lost somewhere? Okay. So two plates are subducting. So this has led to the birth of volcanic mountain. This volcanic mountain, when it rises to the surface, it will form island. This is how many islands of the world in the oceans have created. For example, Japan. In Japan, you can see so many islands. Those islands have created like this. So there is something called Pacific plate. You know that. This is called Eurasian plate and Philippines plate. Three plates are there. Those plates are colliding with each other. Where Pacific plate is more stronger, so it is subducting inside Eurasian plate. It has created this island here. So like similarly, Indonesian islands are also created due to the collision between this Sumatra plate and Indo-Australian plate. Okay, and also there is North Caribbean islands, right? So those islands also have been created due to the same process. Understanding many islands of the world are created due to these tectonic interactions where two plates are conversing with each other. Okay, and here you can see in the ocean there is this depth, deep is forming here. This deep is called, some depressions are called trenches. So what they can ask you is landforms along different plate boundaries. So we are studying landforms along convergent plate boundaries. Along convergent plate boundaries, what is happening? There is subduction happening, and there are islands forming. Correct? Volcanic mountains and islands are forming, and also these trenches. So trenches are common features of convergent plate boundaries. Always remember, trenches do not form during divergent plate boundary. They form at the zone of convergent plate boundaries. So again, you know that what is happening here? Plates are diverging. That's why it is pushing towards this side and getting destroyed. But here volcanic eruption is happening, right? In the beginning, I had explained you that the energy is coming to the surface mantle plume, and it is also erupting in the form of volcano here, right? So here, what is happening when a volcano is erupting? It is developing new crust. It is developing new crust. Correct? When they are separating, what is happening? New crust is developing. Understanding? The new crust which has developed here, at the same level, it is getting destroyed here. Here, new crust is constructing. Here, crust is destructing, getting destroyed. So that is why convergent plate boundaries are called destructive boundaries, and divergent plate boundaries are called constructive boundaries. Very easy. Okay. So here there is Rift Valley forming, right? So rift valleys are the features of convergent plate boundary or divergent plate boundaries. Divergent plate. For example, Red Sea. You take the example of Red Sea. Correct? So Red Sea, what happened? You can see Red Sea. You can take the real example. Currently, Africa is splitting. All of you know that. Correct. So why it is splitting? So this is Africa, okay? And this is Arabian Peninsula. Earlier, they used to be attached. They were together. This land was together. So it used to be like this. This is okay. What happened? They have developed this divergent plate boundary, where energy is coming from the depth and it is hitting to the mantle where they're separating. That's why divergent plate boundary is creating. So this boundary runs like this actually. Okay. I will draw again. Just wait. Okay. Assume earlier the Saudi Arabian Peninsula was also part of this. What happened? They developed this divergent plate boundary. This divergent plate boundary was running like this. This is the divergent plate boundary along this. What happens along divergent plate boundary? Two plates separate. Correct? Two plates separate. New crust develops. So you can see a rift here. This is called Great African Rift Valley. Right? That rift is already, rifts are the features of divergent plate boundary. And the same boundary is running through here. That's why actually this part has got already separated. So that's why there is a gap here, right? There is a gap here. And there is this Saudi Arabian Peninsula. Arabian Peninsula. Okay, so there is this Arabian Peninsula. So between Africa and Arabian Peninsula, there has formed, this is the rift actually. In this rift, water rushed. So this has formed a sea. What is this? Red Sea. And in future, these will again diverge more, right? And Red Sea size will increase. And this part is also separating. This is called Somalian Somalian plate. Somalian plate. This will also separate because there is divergent plate boundary. This will go this side and this will go this side. This is Somalian plate and this is called Nubian plate. What is this called? Nubian plate. Earlier there was one African plate. Now Somalian plate and Nubian plate. So examples. So like that in the world there are different plates. You can go and read. Okay, there are a list of plates. Major plates. Which are the major plates? So what is the meaning of plate? Plate means lithosphere, a block of lithosphere, right? So which are moving. So there are 7 major plates. What are they? North American plate. Biggest one is what? Pacific. Then Eurasian. Other North American, South American, African, Indo-Australian. So these are major plates, right? And there are some other minor plates also like Nazca plate, Caroline plate. Huh? Cochin. Cocos plate. Nazca plate. Fiji na? Okay. Okay. So understood all of you? So you can further it. Based on this, many theories. I mean, this was explained by plate tectonics theory. What I have explained just now is what? Plate tectonic theory. This theory came up in 1967. Earlier theories were. First theory was continental drift theory by Alfred Wegener. Second, B-floor spread theory. No. Convection theory, right? Second one.
Convection.
Convection, current theory, and then B-floor spread theory, and last one, plate tectonics theory, the final one. So plate tectonics is the combination of all of these aspects. Alfred Wegener did not know all of this. He did not know the concept of plates. He did not know the structure of the Earth interior. He just said there was one big continent. What he said was there was one big continent in the beginning. This got divided into two continents, bigger continents with the names Laurasia and Gondwana. Right. So these two bigger planets again further split up into different continents. So part of Laurasia which got split up later were North America, Eurasia, Greenland. So they are measured here. South America, Indo-Australia, Indian and Australian plates. Yes, next. Africa, Antarctica. Okay, so all of these plates. South America, Africa, okay, and this Falkland Islands, Madagascar, everything in the southern parts. Okay, so India was part of this. India was part of this is Gondwana, right? Gondwana, and this is Laurasia. India split up from here, right? So this is India was part of Gondwana Island. So let me explain the journey of India and briefly. So India was part of Gondwana land earlier, right? So this was the India total. Himalayas were not there, correct? So there was this Madagascar and Africa, right? Like this. So India separated from here. There is this equator. India separated and crossed the equator. Earlier, India used to be below equator in the temperate region. After that, now it has come above equator and now it is in the tropical region. Correct? So it's separated from Madagascar. Separated from Madagascar. You know that while traveling, it passed through. There is one hotspot here. Near this Madagascar. What is that hotspot? Reunion hotspot. Reunion hotspot. Okay. So when India came above this Reunion hotspot, what happened? What is a hotspot basically? Hotspot means there is a fixed source of magma. There is a magma chamber below. There is a fixed source of magma. So whatever the land which passes through that, it erupts there and it will create some volcanic land from above. So India was also passing through that hotspot, right? So below this there is hotspot. So which has created a plateau here. What is this plateau called? Deccan Plateau, right? And also when India further traveled, okay, this area got exposed. Okay, so this area has created what? Lakshadweep Islands, that we say. Lakshadweep Islands. Lakshadweep Islands basically coral islands, but before that there were volcanic islands. Okay, so you know that Lakshadweep Islands, Maldives, and many islands, Seychelles, and many islands formed like that. Okay. So once India, actually India is not a single plate. You know that, right? One of the plates is what? This Eurasian plate. This is one single plate. This one single plate is entirely traveling towards north. And there is this Eurasian plate. There is this Eurasian plate. So this is basically what? Oceanic plate. This is basically oceanic plate. Whereas Eurasian plate is what? Continental plate. So when these two collided, so what happened before collision is, when they came very close, there is this water body, right? This is sea. This name of this sea is Tethys Sea. Tethys Sea. So rivers joined this sea, right? Like many rivers flow to Bay of Bengal right now, correct? Similarly, many rivers from both the sides were draining into this Tethys Sea. Rivers carry sediments. Sediments are getting deposited in this sea, right? So sediments are getting deposited in this sea, and sediments will become, through the process of lithification, sedimentary rocks. So rocks are forming in the middle, right? This is called geosyncline. Now it is called what? Geosyncline. Understanding? So Tethys Sea was a geosyncline. In geosyncline, sedimentary rocks are forming, and these two plates are approaching. I mean, basically, this Indian plate is approaching towards Eurasian plate. What happens? Compression, right? So this creates folding. So that's why Himalayas are formed. They are fold mountains. Himalayas are formed. Once Himalayas are formed, still this plate is moving towards Eurasian plate. What happened at fine time? This Indian plate. See, when they were very near to each other, when they approached very near to each other, in the middle there was this sediment formation happened, right? In this geosyncline. So these sediments started getting compressed. That had led to the folding. So that has created fold mountains. But the height is still less. But later on, what happened? This Indian plate subducted inside Eurasian plate. Once the subduction started, they got uplifted. This subduction is still going on. The height is further increasing. You know that every year, few centimeter, Himalaya grow. Why they grow? Because this Indian plate is subducted inside Eurasian plate. More it subducts, it will get destroyed here, but it will uplift here. Okay. So this is how Himalayas are formed. These are called fold mountains. So in the world, wherever such mountains are formed, they are called fold mountains. One fine example for this, Himalayas. Other examples also you should know. So Rockies are also fold mountains in which continent? North America. Andes are fold mountains in South America. Alps are fold mountains. They are all fold mountains only, not block mountains. They're okay. Alps are fold mountains in Europe. Atlas in Africa. So these are what new recent ones. There are other old fold mountains also. For example, Appalachians. Appalachians are old fold mountains. Appalachians in North America, same, right? So in the North America, if you just observe, in the North America, western side there are mountains. These are Rockies, and many other ranges are there, but mainly Rockies you consider. And there are Appalachians. Appalachians are on the eastern side. Okay. And Appalachians after that, Urals. Where are Ural mountains? Russia. Okay. So Ural mountains divide Russia into two parts. Russia has two parts. One European part, Asian part. European part lies east of Urals. Asian part lies west. Sorry, European part lies west of Urals. Right, west European part, east Asian part. So Urals are in Russia. Just remember this. And Aravalis in India. Aravalis are also what? Fold mountains. So these are oldest fold mountains of the earth. Okay. Where were we? So Alfred Wegener, right? So yeah, Alfred Wegener said this. Alfred Wegener said there was this one single continent. What was this continent called? Pangaea. Pangaea divided into Laurasia and Gondwana. India was part of Gondwana. So India started separating from Gondwana around 200 million years ago, right? So around 50, 60 million years ago, Himalayas are formed. Around 50 million years ago, it reached Eurasia. Okay. So with this, what Alfred Wegener is saying is that the continents are separating from each other. Right? He was right in what he said, but he did not know why. Correct. He has given some proofs like the few proofs like if you compare the ages of rocks on all the sides, they are same on both sides, and there is something called placer deposits. You can go and check with the proofs. Okay. Can you do that? It will simply drain time. But one point that Alfred Wegener did not know is he did not know the reasons behind the splitting up of continents. He knew that continents are splitting, but he did not know why. He said that some tidal force from moon is impacting so much that the plates are splitting apart, and there is something called buoyant force that is making these continents float. Right? These are large continents. How can they not sink? Right? He said there is something called buoyant force. Another force, he said there is something called pole fleeing force. Pole fleeing force means due to rotation, the mass wants to concentrate at the poles. So that's why continents are trying to flee towards the poles. But all these were observed. So nobody accepted this. So later on, eventually in plate tectonics theory, we understood. Now you know why they are splitting. Why they are splitting? Because the energy is coming from the interior of the earth. Two reasons: decay of radioactive material and the primordial heat. That movement of energy is called mantle plume, right? So that is causing divergent plate boundaries, and all of the rest of the story you know. So one more thing, convection current theory is the same thing. Whatever that I explained, right? That is convection current theory. That energy is radiating from the core, outer core, and this mantle region, right? So this is creating one convection cell. Just now explained, right? That is convection current theory. So seafloor spread theory is also similar, right? Seafloor spread theory said that. So in the oceans, there are divergent. Even Harry Hess did not know, who explained it. He did not know that there were these lithospheric plates which are separating. He just said that there are some ridges. What? There are some ridges at the center of the ocean. What are there? Ridges at the center of the ocean. And as you go away from these ridges, on both sides, at similar distance, the rock properties are same. How they are same? Because they were once together. The ocean floor is spreading. That's what he explained. But he did not know why exactly. Later in plate tectonics theory, we understood everything. It is spreading because energy is coming from the within, they are diverging, all of that. there is divergent plate boundary. It is creating this ridges. Always remember one more thing: ridges are at the divergent plate boundary only. These ridges are at the divergent plate boundary, and there is rift valley also at the divergent plate boundary. Okay. So on this, please go and further read on this. Okay. Have you understood the concepts of plate tectonics? There is one more boundary called transform plate boundary, where two plates move side by side. They're not coming together and they're not separating. They are moving side by side. Okay. Okay. But earthquakes do occur in all these earthquakes do occur in all these plate boundaries, whether it could be convergent, divergent, or transform. Right. And volcanic eruption is also common along them. Okay. Okay. So what we have completed till now? Tell me things that we have completed. Origin of the earth we have completed. Interior of the earth. Solar system. Okay. And plate tectonics. Understood the concept. Remaining things you go and study. Okay. We'll start with geomorphic process. Geomorphic process. So geomorphic process. What is the meaning of geomorphic process? Geo means earth. Morph means changes. Right. Morphing process. So earth surface is not constant. Right. It is not same. Today you are seeing Himalayas. Right. Once in future time, these Himalayas will get eroded completely. There will be completely plain area. There can be, because rivers are eroding mountains. Once this upliftment process stops, what happens? There is no growth, only reduction. You can say Aravalis. Aravalis once were taller than Himalayas, but now they are short mountains. Correct? They are relic mountains. So Earth's surface is not same, right? So Earth's surface always keeps on changing. The changes are due to time, the structure of the rocks, right? And the process. Process is geomorphic process. Okay, there is one famous line that says that Earth, this geomorphic process are subjected to changes due to structure, time, and process. The process are geomorphic process. We'll understand what are those processes. Okay. Understood what do we study in this chapter? We study the changes are happening on the Earth's surface and why. On what? Due to what forces. So those forces are called geomorphic forces. So there are two types of forces. Which are them? Geomorphic processes. Basically, we divide into endogenic and exogenic. Okay, this part will finish first, then we'll come to this. Okay, endogenic and endo means from the within interior of the earth. Exo means exterior of the earth, outside and at the surface, right? Exterior. That's called endogenic and exogenic. So we'll take up this endogenic. Okay. Endogenic. What is the meaning of endogenic? The forces which are generating within the interior of the earth. All of you are clear with this? Okay. We divide again this endogenic into two types. What are they? Sudden movements. Okay, sudden movements are all no, sir. Sudden movements and flow movements. Flow movements we call them as technically diastrophism. Always remember, they might simply ask what is diastrophism. Diastrophism is endogenic force, endogenic movement. Endogenic movements means the movement which is generating from the within of interior of the earth, right? And slow means does not occur suddenly, like earthquake occurs suddenly, right? So it cannot be part of slow movements, right? It should be part of sudden movements. Understanding this? Okay. So diastrophism and the sudden movements. Sudden movements are basically two types. Volcanism and earthquake. Volcanic eruption occurs in no time. Suddenly it erupts, spontaneously it erupts. So that's why it is sudden movement. Earthquake also spontaneously happens in no time. That's why it's part of sudden movement. In slow movement, we again divide further. So keep this aside. In endogenic, sudden movement, keep this aside. We will study separate. Now focus on this slow movements. So tell me again, geomorphic process are divided into endogenic and exogenic, right? Endogenic we have divided into sudden and slow. Slow movements are called diastrophic movements. Diastrophism. That process is called Diastrophism. So slow movements or diastrophism. This can be further divided into another two types. Epirogenic and orogenic. Another epirogenic and orogenic. Okay. So here let me explain. So here focus. Many people get confused here. Epirogenic movements means it creates large continental parts. It creates continental parts, whereas orogenic creates mountains. Always remember, oro means here mountain always. Orogenic means related to mountains. Always remember. It could be, there are two types of mountains, all of you know. Which are they? Fold mountains and block mountains. Just now we studied formation of Himalayas. Correct? That should be orogenic movement, right? Because Himalayas are mountains. So mountain forming process are called orogenic. Correct? So it can be, we'll discuss further. Epirogenic means continent building. Continent building means new continent is coming from below, right? From above water, or it is getting inside the water. New continent is coming to the surface. But here mountains are not involved. Continent is involved. Rest of the continent is involved. Understand this? For example, in India, for example, if you take eastern coast is emerged, it has come above water, right? So what does it mean? It should be part of orogenic or epirogenic. It is not orogenic because there is no mountains. It is not the process of mountain formation. So it should be epirogenic. Okay. So some part got submerged. Then it is what? Orogenic. So raised beaches, submerged beaches, these are examples for epirogenic movements because there are no mountain formations. Understand this? So these are continent building process. These are mountain building process. Correct? So epirogenic can be further divided into two types: uplift and uplift movements and subsidence. Uplift means, so one thing I'll tell you, remember everybody focus here. This is Earth. If the force is coming from within, because we are studying endogenic movements, right? Forces are coming from within, interior of the Earth. The force is radiating away from the center. What happens? It creates uplift. Here there will, for example, raised beaches, because the force is coming from the interior of the Earth and the force is radiating away from the center. That is why there is this bulge you can see on the Earth crust. It is giving rise to new continent, new continental part, new land. Correct. So this is called uplift. If the force goes in, force is towards the center. Then what happens? Mute ಮಾಡಿ ಇಲ್ಲ.
Sir, sorry.
Okay. So yes. So what is happening here? The force is moving towards the center. Then there is this subsidence. Here you can see subsidence. One fine example for subsidence is, you have to remember this. You know, there are mountain Himalayas here, and there are Arakan mountains in where? Myanmar. These mountains were earlier continuous. So Andaman Nicobar is still there, right? Like this. Now what happened? This middle part got this process, subsidence, right? So you can see now there are no mountains in the Bay of Bengal in the middle. Now we can only see the Andaman mountains, Andaman and Nicobar Islands. Understand this? So this is one fine example for subsidence. So understanding. So here force is radial. Radial means either towards the center or away from the center. This is radial movement, right or wrong? So epirogenic movement is what? Uplift and subsidence. These two movements are radial movements. They are radial movements. Okay. Now consider the example of Himalaya formation, where two plates are colliding each other, right? So here there are geosyncline, this folding happened, fold mountains created, Himalayas here in the zone. Here the force is not towards the center, away from the center. Correct? It is what? Tangential, like this. The force are horizontal forces. Correct? You can see here compression. This is what? Horizontal force. Always remember epirogenic movements, radial force, radial moment, and orogenic movements are, there is tangential force or tangential moments or horizontal moments. Understood everybody? Okay. So nothing much about epirogenic. Come to orogenic. This is important. Just understand the difference. Have you understood the difference? Once you understood the difference, let us further discuss about orogenic movements. Orogenic movements. Orogenic means what? Mountain building movements, mountain building processes. Then horizontal movements, tangential forces. Right. So what can happen? These two plates. So this is always remember orogenic movements leads to the movement of plates. If anything is related to the movement of plates, that is orogenic movement. Correct? Because the plates are moving away from each other. Horizontal movement is involved or tangential movement is involved. Correct? So we can see there are two processes here within this. One thing is called folding and another is called faulting. Folding and faulting. So folding and faulting are part of orogenic or heterogenic? Orogenic. So let us take up folding. Already you know folding. Let us revise again. Folding means there are two blocks of earth, lithospheres, right? When there is compressive force, always remember for folding to occur, what force should be needed? Compression forces. Compression, right? They have to come together and compress the matter, the sediments which are formed in the geosyncline. So there is always compressive forces, remember, in folding processes. Correct? So this folding will lead to fold mountains, as we studied just now, like Himalayas and other mountains. What about faulting? In the faulting, there is basically there is tension force. There is tension. Tension means the plates are separating from each other. This force is called tension. Tension force. Okay. So when they are separating, what happens? You know that already. You know that the middle block falls down, creating a rift. Correct? So assume three bigger blocks. Three bigger blocks. So if there is tension force between these two plates, what happens in the middle part? It falls down. Correct? It falls down. This is called faulting. Whenever there is faulting, there creates this rift valley. This is called rift valley. Technically, it's called graben. That technically it is called graben. And these two blocks will become like mountains. Correct? These two are becoming like mountains, right or wrong? So these are called block mountains. This is how block mountains are called. Fold mountains are the result of folding, whereas block mountains are the result of faulting. This is faulting, where there is tensional force. Basically, there is what? Tensional force. So this is called normal faulting. Again, there are different types of faults. Don't worry much about that. This is called normal fault. Okay. So your middle block is called. This is called hanging valley also, right? Hanging block. Hanging block, right? Hanging block. This block is called hanging block, and this is called fault line. Weak zone, right? Weak zone. This is called fault line. Along this, the block moves down. Rift. And this is called, these are block mountains. They are technically also called forced. Forced. And graben. Technically, forced and grabens are the landforms created by folding or faulting. Faulting. Forced and graben. This graben is also called rift. So basically, which type of force is there? Tension force. But this is not always true. In case of fold mountains, there is always compression force, compressive force. But in case of faulting, generally there is tension force. But some cases there is also compression force. Due to that also faulting happens. Let me explain now. Take the three blocks just as we have just taken in the example we discussed. Yes. So these are three blocks. Assume there is compression force. Assume there is compressive force. What can happen here? Due to compressive force, the middle block sometimes what it can rise. Instead of falling down, it will rise. This is called reverse faulting. What is this called? Reverse faulting. So which force is there? Compressive force. Due to compressive force, faulting is happening. Simple? Okay. So again, this will become what? Block mountain or technically forced. Forced or block mountain. And this is what? Grabens. Two grabens. So example for such block mountains, Satpura, Vindhyas in Europe, Black Forest and Osges in France. Okay. They are flowing in Rift Valley. Damodar River, Mahanadi, all of them flowing in the Rift Valley. Okay. So we'll come back to that in Indian geography. Have you understood folding and faulting? So folding and faulting are part of heterogenic or orogenic? Orogenic. In orogenic, there are two movements. So we have completed sudden slow movements we have completed. Heterogenic and orogenic. Come to sudden movements. In sudden movements, these are important. Sudden movements, volcanism and earthquake. So which one we shall take up first? What is your favorite? Volcanism. So already you know the process volcanism. What happens? There is asthenosphere. There develops some weak area cracks along the joints of the rock blocks. So through that the magma erupts to the surface. So that eruption of magma is called volcanism, right? So when once it comes to the surface, what is it called? Lava. Okay. So now that lava or magma can be of two types: basic lava or acidic lava. Basic or acidic. Always remember this is very important. It's very most important point. Basic lava, acidic lava. Basic means it has more silica content, whereas sorry, it has less silica content. And acidic means there's more silica content. Okay, remember it. Acidic lava contains more silica content. Okay, acidic lava is highly viscous. Viscous like honey, right? You can take honey as for your imagination. This is like honey, viscous, highly viscous. It does not flow like water. It flows in a very slow rate. And basic lava is like water. It's like water. That means basically it's a less viscous. It's more liquid, right? You can take it's like water. So have this imagination always. This is like water. It flows very easily. If you drop it somewhere, it will flow. It will spread very easily in all the regions. Okay. Now take up this. This is Earth's surface. There is this asthenosphere. From asthenosphere, magma is erupting through the cracks, right? So here, assume this is what? We assume it's a viscous. It is what? A viscous in the sense it's acidic lava, acidic magma or acidic lava. So you know that acidic lava is viscous. Viscous means it does not spread easily, but it develops. It grows in height. Height ಜಾಸ್ತಿ ಆಗುತ್ತೆ, but width it spreads in lesser area. Why? Because it's not like water. It can spread. It is like honey. It can accumulate at one place. So it will develop mountains like this. Correct? Here, take the structure of any volcano. There is this vent, main vent. What is this called? Main vent. And there are side vents. There are side vents, right? So usually at the top there is this cone. What is this cone called? Cinder cone. So no. This is this depression. This is called crater. Crater. And there are side small cones can develop. These are called cinder cones. This is the structure. So like that, you can see some landform is creating at the surface, right or wrong? Some landforms are forming on the surface of the earth. And sometimes some landforms can create within this. So what happens here is, there is this main sources here, right? There is some vent here. Okay, there is a conduit. Through this conduit, I will take red to indicate magma. So from asthenosphere, magma is coming, and generally it will store at a place. Correct? This is the main reservoir. From here, some magma is getting stored here. So every time volcanic eruption happens, it will not directly come from asthenosphere because it is at depth. So from what is this called? This is called magma chamber. Magma chamber. Through this magma chamber, continuously volcanic eruption happens. So depending upon the characteristics or type of lava here, type of landforms are formed. Okay. So basically, what if this supply cuts off? What if the supply cuts off? It will cool slowly. It will become a hill inside the earth. Okay, whatever. Let us. Okay, so this is also creating a landform. Once it cools, once the lava cools, it will form landforms. So landforms can be volcanic landforms can create. Volcanic landforms can create either on the surface of the earth or inside the earth. Understanding? So that is why we divide volcanic landforms into two categories: extrusive and intrusive. Extrusive means on the surface. Intrusive means within the surface. Okay. So now we study extrusive landforms and intrusive landforms. You know the meaning of extrusive and intrusive landforms. Extrusive landform means landforms created on the surface of the earth due to volcanic eruption. Okay, what time we need break? Come to 4 hours, huh? ಅದು ಎಷ್ಟು ಗಂಟೆ? 1:30 to 2. Half an hour ಸಾಕಾ? 1 to 1:30. I mean, let us finish physical geography once. In 30 minutes, I can finish because the rest of the topics will be quick. At least we'll finish geomorphology and climatology. After that, okay. Okay. Anyway, I'll leave at 1:30. 1 to 2. I mean, let me finish at least one section so that I will be a little satisfied, right? We'll finish geomorphology at least, please. Okay. So listen here. Then I'll be very quick here. Magma chamber. So from magma chamber, volcanic eruption is happening, right? So sometimes there can be a tall mountain like this, right? So what? There are different types of. This is creating mountains, right? So what kind of mountains they are called? There are different types. Okay, they can be either shield volcanoes or composite volcano. First, let us study these two. Shield volcano. These are most famous ones. See, if the lava or the magma is more acidic, it is more viscous. When it's viscous, it does not spread long distance, but it will grow in height. Grow in height. So this will create composite volcanoes. Composite volcanoes are created due to viscous lava, acidic lava. Composite volcano, why we call it as composite volcano? Because once it erupted, it will develop like, for example, right? So composite volcano has, okay, just listen here. Focus here, everybody. Okay, so there is this vent, right? Lava is erupting. So once it has erupted, it has developed a small hill. Next, this is viscous lava. Viscous lava means at the vent, this lava, when it condensifies, it will create a block in the vent. Why it creates a block? Because the viscous lava has condensified. Understand this? It has condensed so high that it has created a block-like structure. So next time when lava has to erupt from here, it is prevented by this block. Correct? So what happens? Pressure will develop inside. Pressure will develop. So if the force is too high, it will break. It will create explosive eruptions. Explosive eruptions. So explosive eruptions is possible only when there is viscous lava. Correct? So explosive one, the upper part might get little destroyed because it has got exploded, and it will eject many things into the atmosphere. They are like gases, like S2S, mainly S2S, carbon dioxide, many types of sulfur dioxide, many types of gases are ejected. Pyroclastic matter. Pyre means fire. Clastic means rock-like structure. Okay, like hot rocks, rock balls are ejected into the atmosphere. Apart from that, ash. Okay, like that. Many things are getting ejected. So what happens eventually? This ejected matter gets settled down. It will fall back, right? Eventually. So it will create a layer like this. So this layer is layer of ash, right? Okay. Now we can see. Now I will draw the structure after some days how it will appear. There is this main lava. This is mountain created to lava, and above that there is a layer of ash. Take different color. There is a layer of ash. Correct? Next time when eruption happens, same thing will repeat, and again lava, and again upon that there is ash. So this is stratified. Different layers are there. Lava, ash like that. Correct. So this is why this is called stratified. Okay, stratified lava or stratus, right? Or it is composite volcano. Composite because it is composed of different layers. Understanding this? So generally, tallest mountains are these composite volcanoes. Tallest mountains are composite volcanoes. So you can see volcanic eruptions in different parts of the world. Tell me a few examples if you remember. Mount Fuji in Japan, for example. Pinatubo in Philippines. Vesuvius, right? Stromboli. Stromboli is called Lighthouse of Europe, right? Lighthouse of Europe, yes. Mount Etna, Krakatau in Indonesia. So there is, you can go through such examples. They might be asked. Recent eruptions, if there are any, please go through them. Understanding that? So composite volcanoes are the result of viscous type of lava, right or wrong? Correct? Because it grows in height. It does not spread, right? It is called composite volcanoes. So another type of volcano is what? Shield volcano. Shield volcanoes are the result of basic lava. Basic lava. Here what happens? The lava eruption will create I already told you basic lava is like water. Once erupted, it will flow to longer distances. It will spread large areas. So this will create what? Shield volcano. So shield volcanoes are not explosive volcanoes. Remember, shield volcanoes are not. Sometimes they can be explosive if it is inside the ocean. If some water inside enters inside the vent, it will become explosive. Otherwise, they are not explosive. Unlike composite volcanoes, they are explosive. Understanding this? So we can take example of shield volcanoes like Emperor Mount is there. You know that sea mounts and all sea mounts. Okay, inside the ocean there are sea mounts. So there is something called Emperor Sea Mount, which is in Hawaii Islands. Hawaii Islands in Pacific Ocean, and there is Mount Mauna Kea, Mauna Kea and Mauna Loa and Emperor. These are shield volcanoes. Mauna Kea is the tallest mountain in terms of height measured from base to top. It is taller than Himalaya and many other mountains. But it is from mean sea level, it is less. But if you consider from base to the top, it is the tallest because it is coming from the ocean depth, ocean floor. From ocean floor, it is emerging above water. If you consider the depth, it is the tallest, Mauna Kea. And second one is Mauna Loa. Okay. So there is one other important, which is in news, another island, another mountain, Kilauea. So this is in Hawaii Islands. Okay. So these are what? Shield volcanoes. Okay. Next, another type of volcano is caldera. Caldera is nothing but it is like composite volcano. It is also a result of what? Explosive eruption. What happens in composite volcanoes? The block creates, it will create pressure. Sometimes pressure will exceed so much so that this entire, once it explodes, this entire volcanic hill will get collapsed on its own. It will be like, after the end, it will be like this because this part has got collapsed. So these damaged structures are called caldera. Okay, caldera. So it may be in the caldera, there can be a big depression, right? There can form a big depression here. Crater will form. This is called caldera lake. Right? Or crater lake. Crater means here there's depression. So shield volcanoes. Next. Composite volcanoes. Caldera. That you have studied. Another type is fissure volcano. Fissure volcano. Fissure means those volcanoes which are continuously erupting, but at a very slow rate, they're not explosive at all. Slowly, they're erupting continuously. They're not stopping at all. Such volcanoes are called fissure volcanoes. One example is, you know that you take this South America and this Africa, right? In between that, in the South Atlantic Ocean, there is a plate boundary. There is a plate boundary. All of you know that, right? Have you gone through this? So in the middle of the ocean, there is this plate boundary. It is a divergent plate boundary where these two plates are diverging. Along divergent plate boundaries, I already told you there are ridges formation happens. Ridges and Rift Valley. Rift Valley and ridges are formations of divergent plate boundaries. Correct? So here, and also told you that a divergent plate boundary volcanic eruption happens. Explain madinala starting ala. So here continuous volcanic eruption is happening along this boundary. That is very continuously it is erupting and at a very slow rate. Such type of volcanic eruptions are called fissure. Always remember fissure type of volcanoes. Another example for fissure volcanoes is our formation of Deccan Plateau. In India, there is this Deccan Plateau just now explained, right? Here, Deccan Plateau, right? So this Deccan Plateau is result of hotspot activity in the reunion. Just now explained, right? So that in hotspot also there is continuous volcanic eruption at slow rate. That has led to the formation of this Deccan Plateau. That is also example for fissure. So what is the meaning of fissure volcanoes? Continuous and slow eruption of lava. Okay, so generally this is basic lava, right? Okay. So these are all what? Extrusive landforms. In the extrusive landforms, we understood composite volcanoes, which are taller, and there is shield volcano. We understood caldera and small volcano is it is called cinder cone. It can be here also, cinder cone. Understood? So these are extrusive landforms outside the surface, on the surface. So there are landforms found within interior also. We can go and check it. This magma chamber, for example, if it cools down, it will become batholith. So batholith, and there is something called still vertical. I mean, what is happening here is this volcanic eruption is happening, right? Magma is coming to the surface. But on the way, if it gets stuck somewhere and it condenses within interior, if it does not comes outside, it will get stuck here only. So here it will condensify, right? So if it is vertical, it is called dike. If it is horizontal like this, it is called spill. And there is something called laccolith, and there is placolith, lapolith, etc. So you can go and check different. So depending upon the shape, we are giving different names. That's all. Don't worry about this. So these are all what? Intrusive landforms. So this batholith is important because earlier there was magma chamber. Now it is cooling off. It has formed a rock, right? So generally these rocks are granite. These rocks are what? Granite rocks. Always remember these intrusive landforms are always made up of granite rocks. Correct? Whereas many rocks, if they are formed, they are cooling off quickly. See, ಒಳಗಡೆ ಇದ್ರೆ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಕೂಲ್ ಆಗಬೇಕಾದ್ರೆ the temperature is higher, so cooling process also very slow because they are in the interior, right or wrong? Yeah, they are in the interior, right or wrong? Hello, following me? Yes. So they are in the interior. Because they are in the interior, the cooling process is very slow. When cooling process is very slow, they will form granitic rocks. Okay. In the oceans, for example, just now explained fissure type of volcanoes. Only once the magma erupts, there is water. So immediately it cools off, right? Immediately that lava will convert into rock, igneous rocks. Okay. So such type of rocks are called basalt. So basaltic rocks forms due to immediate cooling of lava. Granitic rocks, which are formed in the interior, they are due to the slow cooling of the magma. So this is volcanism. So we'll finish earthquake quickly. Focus here. So earthquake is one of the important sources to study interior of the earth. All of you know this point. This is the most important source for studying the interior of the earth. It is an indirect source to study interior of the earth. Okay, what is earthquake? Simple, in simpler terms, like tremors or shaking of the earth. Why it shakes? For fun? Why tremors are created?
Energy.
Due to release of energy. See, you already know what is a fault. Fault is like a weak zone, right? So there is a block of earth. There is another block of earth. Okay, it could be along plate boundary or it could be anywhere in the interior. Along plate boundary, it is common. There is a block of two blocks, right? Two plates. So here two blocks are resting on each other, right or wrong? These two blocks are resting on each other. So over a period of time when they're resting, they will get fatigued, like, right? They want to adjust, right? They want to overcome. Why they are attached? Because there is friction force between them. But these plates, they tend to overcome the friction. They tend to overcome the friction force. They want to just adjust themselves. Sometimes what happens when they try to adjust, it will at one point what happens, there creates a friction or there is a movement. So that creates an energy at one point. This point is called focus. At the focus, energy is releasing. At the focus, those energies, all the seismic waves or earthquake waves are originating at the point. That point is called focus. It is in the interior. Correct? It is in the interior. So let me draw it again. So now consider these two blocks now. Okay. This is first block and this is second block. So this point where energy is releasing, what is this point called? Focus. So from here, energy is radiating all the sides. Correct? Energy is radiating all the sides immediately. Correct? So which part? Here there is surface. Okay. So energy when radiates all sides, right? You can see this place which is lying exactly above this focus. This place is on the surface which receives the energy for the first time because it is the nearest point on the surface. This point is called epicenter. This is called epicenter of earthquake. So whenever earthquake happens, you should know where is the epicenter because maximum damage will be around the epicenter because it's near to the focus. Highest energy will reach this point. These are called seismic waves. Seismic waves that are traveling in all directions. Correct? Like if it is here only, if it is the focus here, in all directions, energy is releasing. So this point above, exactly above focus will be, this point will be epicenter. Okay. Now we'll study the seismic waves. Okay. So these waves are generating, right? We'll study seismic waves. So waves, seismic waves will divide into two categories, P and So actually, body waves, and the surface waves. So as the name suggests, body waves means those waves which are generating in the interior only, and they will remain within the interior. Okay. So surface waves are waves created a second afterwards on the surface. How they will create? We will discuss later on. First, take up body waves. Body waves mean from the focus from the focus. Focus is also called hypocenter. Remember, focus is also called hypocenter. Okay. From hypocenter of focus, energy is released. Okay. So the first waves that generates are called P waves. Primary waves, yes. They are called P waves. Okay. So another waves follow P waves, they are called S waves. So they are within the interior, right? This is the surface. They are within the interior, that is why they are called body waves. Okay. So P waves and S waves. First waves to produce are P waves. And P waves are fastest. They're very fast. Immediately when they release, they will come and hit to the surface. As soon as some friction occurs here, immediately the energy releases from the focus, the waves come and hit to the surface. They're fastest. Always in P waves are fastest. They're first to produce, and they're not first to produce. They produce along with S waves, but because they're fastest, they will reach the surface first. Okay. And remember of some characteristics of P waves. P waves travel like they travel both in solid as well as liquid. So they are like sound waves. They are longitudinal in nature. Always remember, they are longitudinal. You know that the waves travel like this, right? If the direction is this way, the particles vibrate along the direction of the movement of the wave. From focus, energy is coming towards surface, right? This is the direction, and the particles also vibrate like this. So here two types of movement is happening. I will draw again. Okay, so focus to the surface. When the wave moves from here to the surface, the particles are vibrating. Sometimes they are getting contracted. That's called rarefaction, and sometimes they get expand. The particles expand sometimes they compress, sometimes they expand. So rarefaction and what? Sorry, not rarefaction. It should be compression, expansion, compression and expansion, compression and again expansion. So here the particles in the interior of the earth, like rocks and other bodies, where the particles are vibrating in the direction of the movement of the wave. This is important to understand. So they are like sound waves. That is why they are called longitudinal in nature. Longitudinal. Understanding? So this is P waves. Once you understand the S waves, you will understand the difference. Take the S waves, secondary waves. When they originate from the focus, they travel towards the surface. The movement will be like this. The particles will vibrate like this, perpendicular to the direction of the movement of the wave. If S wave is traveling this way, the particles will vibrate perpendicular to it. For P waves, along the direction of the wave. But for S wave, perpendicular to the direction of the wave. Okay. So online error ಕೇಳಿಸ್ತಿದ್ಯಾ?
Yes, sir.
Voice pause in between frequently, others also facing. Are you facing voice issue?
No,
ಸರ್
sir.
ಈಗ ಅವಾಗ್ಲೇ ಇದು ಆಯ್ತು.
Okay. Oh, we'll take break then. No, wait. So if I complete earthquakes, we'll shift on to climatology. Okay. Rocks, I will explain rocks in 5-10 minutes. Shall I explain rocks here only now? Huh? Rocks without board. Okay. Can I explain rocks? So, okay, there are. So, what are rocks basically? Like, I'll come back to that. Okay. Meanwhile, I will finish rocks chapter. So, what are rocks basically? Aggregations of minerals. What are minerals? The rocks are made up of minerals. Always remember. What minerals are made up of elements. So, tell me the elements of the earth. Highest element of the earth. highest element of the entire earth. Not silicon. Silicon. Iron. Next. Huh? Oxygen. Okay. So if you take this for entire earth, iron and oxygen. For crust, silica is the top. No. Crustal highest element is oxygen in the crust. Second is silicon. Okay. Third one is aluminum, and fourth one is iron in the crust. In the crust, fourth one is iron. So these are the top. So these are all elements. Silicon, iron, then we have aluminum, magnesium, etc. Correct? Okay, these are elements. Elements combine together to form minerals. Minerals will combine together to form rocks. Clear? So there are different types of rocks. Three types of rocks. Which are they? Igneous rocks, sedimentary rocks, metamorphic. Igneous rocks means they're directly forming from the condensation of magma or lava. Just now I explained granite, for example. Granite forms within the interior of the earth. I told you, right? Due to the slow cooling. Right. Here the magma is cooling and forming rock. So if the condensation of magma or lava results into some type of rocks, they are igneous rocks. So they're directly forming from the magma or lava. They're the first rocks to form because they're forming directly from the magma or lava. Correct? So next type of rock is what? So sedimentary rock. What happens here is these igneous rocks, they are eroded. Eroded means yes. So erosion means, for example, take a river. River is flowing in a rock. The rock will get eroded means it will convert into small sediments due to the force of those agents like water or wind. Those sediments will travel and get deposited somewhere. After erosion, transportation, somewhere they will get deposited. Correct? So this is called erosion. So once the sediments get deposited somewhere, for example, consider that river is flowing from Himalayas and flowing to Bay of Bengal, for example, like Ganga River. So Ganga River is carrying a lot of sediments from those after eroding those rocks, and all these sediments are getting deposited in the oceans, in the continental shelf, first part, where these sediments get compacted, cemented each other. Okay, and due to that process, it will convert into rock. That rock is called sedimentary rock. Sedimentary rock means it is the due to the compaction of sediments. This process is called lithification process. So lithification process is the process for formation of sedimentary rocks. Always remember. Okay. So we see examples for sedimentary rocks also, like limestones, dolomites, chalk. Okay. So shale, all of this. Okay. So all of these are example for sediment rocks, which are formed due to the deposition of sediments. Igneous rocks, for examples, granite, for example, granite, then basalt, then volcanic breccia. So these are some of the examples of igneous rocks. Igneous rocks means rocks which are forming out of the condensation of magma. Correct? Next type of rocks are metamorphic rocks. Metamorphic means its structure is changing, its composition is changing. Why it is changing? Because it is applied under high pressure and high temperature over a long period of time. Correct? For example, granite. If the granite, if it is compacted under high temperature, okay, for longer duration, it will become gneiss. Okay. So metamorphic means existing rocks will convert into some other rock. So that existing rock can be igneous rock, that existing rock can be sedimentary rock, or that existing rock can be a metamorphic rock. If there is some modification is happening due to temperature and pressure, that is called metamorphism. Okay. So here you should understand two more things in metamorphism. So there is something called contact metamorphism and regional metamorphism. Contact metamorphism and regional metamorphism. So just now I explained the subduction zone, right? All of you remember what is happening in the subduction zone? Online board share ಆಗಿದೆಯಾ?
Share ಮಾಡಿಲ್ಲ.
ಮಾಡಬೇಕಾ ಮತ್ತೆ? So all of you remember subduction zone. Since subduction zone is what happening, one plate is subducting inside another plate. The plate which is getting subducted is reaching asthenosphere, right or wrong? Hello. It is reaching asthenosphere, right? Huh? ಇದೆ ಅಲ್ವಾ? 909 ಅಲ್ವಾ? ಬೇರೆದಾ?
Yes, sir. 909.
हाँ हाँ भाई स्क्रीन शेयर है ಸಾಕಾಯ್ತಾ ಹಾ ಪಾಪ ಇವಾಗ ತಾನೇ ಕಾಲೇಜ್ ಮುಗಿಸ್ಕೊಂಡು ಬಂದಿದ್ಯಾ ಎಷ್ಟು ಲೋಡ್ ಆಗ್ತಿದೆ ಮೈಂಡ್ ಅಲ್ಲಿ ಎಲ್ಲ ಓಕೆ yes listen here. So in subduction, you know what is happening? One plate is subducting to another plate, right? So here this plate, when it subducts, it creates pressure in the asthenosphere, right or wrong? It is creating pressure in the asthenosphere. So once, now what about the rocks which are in contact with this magma? Say these rocks along this boundary. So here temperature is rising, right, in this zone, these rocks, because they are directly in contact with the magma, right, or this high temperature zone or high pressure zone. So this is called contact. Here what happens, the rocks here, the rocks in this region get metamorphized. They will convert into some other form. Their chemical composition, physical property changes because they are subjected to high temperature and pressure. So this is called contact metamorphism. Regional metamorphism is over a long region, like along entire plate boundary. Correct? Like for example, this region, this is, for example, this region, okay, this is not in contact with the magma, but still it has created, it has raised the temperature in all this region, and it also raised the pressure in the all this region. So it will also lead to metamorphism in the regions which are away from this contact zone. So this is called regional metamorphism. Contact means directly in contact with the magma. Regional means in the entire region. Okay. So this here metamorphism would happen quickly, immediately. It takes less time, but here it takes longer time. That's all. Right. So just remember some of the example, like granite will convert into gneiss. Gneiss again can be subjected into metamorphism to become gneissoid. Correct? And limestone, for it's a sedimentary rock. Limestone can convert into marble. Quartz can convert into quartzite. So like that. Sandstone. Sandstone also quartzite. Yes, and shale to schist. Shale stones can metamorphose into schist. So like that, you can go through some other examples. So these are important examples. Okay. So have you understood three types of rock? Igneous rocks means they're directly formed from the condensation or cooling up of lava or magma. And sedimentary rocks means any rock can become sedimentary rock, provided getting eroded and sediments are forming. It can be any rock, right? And metamorphism also, any rock can become metamorphic rock, just that it has to change its characteristics, physical and chemical both. Okay. So one more point important for exam is, in metamorphism, there occurs two types of processes. That is called foliation. Foliation and lineation or bandation, right? Lineation is also called bandation. So formation of bands. So consider this is a metamorphic rock. Okay. So what happens in metamorphism? Huh? Foliation or lineation, right? Okay. Foliation and lineation will take up these two converses. Okay. Foliation and lineation take up this. So this is the metamorphic rock. In metamorphic rock, what is happening? The physical and chemical properties of rocks are changing. Here, in this process, the grains in the rocks are also rearranging. That's why the physical properties are also changing. Rearranging of grains inside the rocks. So what happens? They will arrange like in one layer. This one single layer. This is called foliation and lineation. Right? Oh, these two are, yes. So these are one type. Another one is banding. Banding is another process. Okay, sorry for that. So foliation or lineation means there is one layer forming, one layer. Okay. So banding means thicker layers do form due to arrangement of the same grains into different zones. Alternative, thick and, or else you can say dark and lighter. Dark and lighter. these blocks. Okay, so there are different bands are created here. One is darker, another one is lighter. Another one is can again be darker, another is lighter. So these are thicker lines. Banding means thicker divisions. Whereas lineation or foliation means just like one line. Within this band there can be a lineation or foliation. Understood the difference? So lineation and foliation, they might simply ask lineation and foliations are the characteristics observed in which type of rocks? Which type of rocks? Metamorphic rocks. So rock cycle is same. We have discussed just now, right now. Rock cycle, for example, there is igneous rock. Igneous rock means for igneous rock, what do we need? Igneous rock, we need what? Magma. So any rock can become magma once it get destroyed, right, and become magma. Any rock can become magma. So consider there is sedimentary rock and there is metamorphic rock. This can become magma. This can become magma once it reaches asthenosphere, and magma once erupt, it will become igneous rock, right? So here condensation process or solidification process, right? Condensation or solidification, right? And then take sedimentary rock. What is most important thing for sedimentary rocks formation? The process is called lithification. Lithification due to sediments. So sediments can be of any rock. These sediments can be of igneous rock, metamorphic rock, or another sedimentary rock can also be. From that also sediments can come. So when the sediments form, when they undergo cementation, they will go, that process called lithification, that will form sedimentary rock. And for metamorphic rock, what do we need? Metamorphism that requires high pressure, temperature, high pressure and temperature, right? So any rock, it could be metamorphic rock, igneous rock, or sorry, any rock, if they are subject under high temperature and pressure, that will become metamorphic rock. So this is the rock cycle, right? So it's very easy. Whatever that we have discussed. So let me complete that earthquake. Where were we for earthquake? Huh? Okay, P waves and S waves. Body waves we are discussing. Body waves means they are in the interior. In the body waves, there are two types. First one are P waves, second one is S waves. P waves can travel through both solid and liquid. S waves can travel only through solid. F for solid. And it also, movement is also like this. If S wave is traveling, the particles will vibrate like correct? Huh? So they're like transverse waves, like electromagnetic radiations. All the radiations that we see, they're transverse like this. Their S waves is also like that. It is like S, right? You can remember S for this shape, right? Transverse waves, and they can flow and they can pass only through solid medium. They cannot pass through liquid medium. Remember this point; it's very important. Okay. Whereas P waves pass through both solid and liquid. They're longitudinal in nature. Longitudinal means when the waves travel, the particles vibrate along the direction. Compression and rarefaction is. Here, solid waves perpendicular, right? Here, like this, like sound waves. Have you understood the difference? And they are fastest. They are first to arrive to the surface. They are first to arrive to the surface because they are the fastest. Now, I told you, for example, from focus and energy radiated, it hits to the surface. When these waves hits to the surface, this rock here. These are body waves, P waves and S waves. They interact with the surface rocks. Due to the interaction between these waves and surface rocks, another type of waves are created here. They are called surface waves. Okay, so they will travel like this horizontally. Okay, so in surface wave also there are two types. Which are they? So which are more destructive for us between surface and body waves? Surface waves. So in surface waves there are two types: love waves and another one is Rayleigh wave. Okay, so just understand the difference. Love waves are fastest here. They're most destructive. They're most dangerous. So here, see, love waves travel like this. When love waves travel like this, the particles also vibrate side by side like this. When love waves travel, the particle vibrate side by side. Remember it. When relay waves travel, the particle vibrate both side by side and also up and down. Up and down will also be there, and even side by side will also be there in relay waves. But more destructive are love waves because they're fastest. Okay. So you can see that's why you can see that shaking, right? On the surface, you that shaking because of love waves and relay waves. So they are the result of. Okay. Next, in earthquakes, most important point here, most important concept is shadow zones. We'll study shadow zones for P waves. Shadow zones means when from focus energy is released, there, right? So here there is seismograph. Here there is seismograph. When you record, you can observe that the seismic waves are hitting this place. So in seismograph, these waves are recorded. But in few places of the earth, here also we can observe P waves. But in few places like here, we do not observe what? In some places, we do not observe these waves. So wherever these seismic waves are not observed on the surface of the earth, that region is called shadow zone. Shadow zone means where seismic waves are not recorded. It should be recorded everywhere, right? Even though with less energy, they travel all the way, right? Everywhere they travel. But sometimes we do not see in few places. So we'll study shadow zones for P waves first. So take P waves. So from here, measure the angle. So you know that this is inner core and this is what? Outer core. From focus, energy is releasing from all the sides. All the sides, energy is getting released. Right or wrong? Right? Okay. So this is say 103 degree. 103 degree. And see, again 142 degree. This is 140 degree. This side also 142. So what is happening here? Observe here. Till 103 degree, we observe in all this region we observe P waves. But after 103, when we are not seeing P waves here. P waves are not recorded between 103 degree to 142 degree. Understanding this? P waves are not recorded between 103 degree to 140 degree on both the sides. From this side also, this side also. In these regions of the world, we do not observe P waves which are generating here. Okay. So why we will discuss later on. But after 142 degree, again P waves are recorded here. Okay. So that is why shadow zone for P wave is between 103 to 103 to 145, 142 degree. Here, this is the shadow zone. Correct? So now tell me why they are absent here and why they reappear. That you should know. Correct? Because they're traveling. You know, when these waves travels, they subjected to reflection and refraction. Reflection and refraction. They change in direction because due to the change in density. You know, the Earth interior density changes as you go deep. So density changes after each layer. Because of that, the direction of P waves also changes. And you know, one property of P waves is that P waves travel through both solid and liquid. This here outer core we have. Outer core is what? Liquid or solid? Liquid. Outer core is liquid. Outer core is what? Liquid. So P waves, for example, up to here, no problem. Once another P wave hits this place, you can see there is change in medium. But still, P waves can travel through liquid medium. There is change in medium. Change in medium means change in density. Change in density will lead to refraction. Refraction. Direction changes. Again, direction changes when it hits to the core because it is solid. Okay, again it changes direction. Again it changes here. That is why instead of coming directly here, it is coming here. Can you see the path? So instead of directly coming this place, it is appearing. So it is reappearing again. In this zone, it is absent because it changes direction because of change in density and composition. So again, here also same thing. Understanding the difference? So this is shadow zone for P waves, which is 103 to 140. Let us take S waves. For S wave shadow zone, take the same thing. From focus energy getting released, there's outer core, right? So S waves, you know that they do not travel through liquid medium. S waves travel only through solid medium. Correct. So they are traveling like this. So up to here, no problem, because it is solid. Up to here, it is completely solid. It's 103 degree, 103 degree. But once it hits to the outer core, which is liquid, the waves will die out. They will not travel. So that's why we do not observe S waves beyond 103 degree on both the sides. So this entire region is the shadow zone for S waves. So shadow zone for S waves is larger. Right or wrong? So shadow zone for S waves larger, which is from 103 degree to 142 degree. Right. And actually, we've understood the different layers of the earth exactly like outer continental crust, then oceanic crust, upper mantle, lower mantle. We have drawn divisions, right? Here, like here we have divided our continental crust and oceanic crust. Then we have divided upper mantle and lower mantle. So this is the line which divides these two places. What is that? How have we understood the divisions? What is that is changing here? Density changing. How have you understood density changing here? Because of seismic waves. We have studied the seismic waves, the path, everything we have recorded, right? All of that we have studied. By that we understood the interior. So seismic waves are the most important points to understand the interior of the earth. All of these divisions we know because of the seismic waves. You know that after each zone, direction is changing, correct? So they can estimate speed and at what zone there is this change, right? So this is called discontinuity. What is this called? Discontinuity. So whatever the divisions that we have made between upper continental crust and oceanic crust, upper mantle, lower mantle, there is division, right? That line is called discontinuity. So there are different names for different divisions, right? For example, Moho discontinuity, which is between crust and mantle. Okay. Gutenberg is between lower mantle and core. Okay. Repeti is between outer core and upper mantle and lower mantle. Conrad is between outer core and inner core. Conrad is at the crust. Continental crust and oceanic crust. Conrad. And Moho is between crust and mantle. And between upper mantle, lower mantle, we have Repeti, right? Repeti. And Gutenberg is between upper mantle and outer core. And last one is layman, layman, outer core and inner core. So you can go and revise them. Have you completed earthquakes? Okay. So with this, we have completed geomorphology. So we will start with climatology, and today we'll finish physical geography. Tomorrow we're not taking classes tomorrow. We'll see. We'll complete. Okay. So come at landforms. Do you need that landforms? Okay. I mean, landforms are not conceptual. You do not require conceptual understanding that. Okay. Important ones I'll do at the end. Let us finish this. Okay.
Sir, at what times again will start, sir?
At what time will you come back? Come exactly at 2:05.